Have you ever wondered what comes after linear algebra and abstract algebra? Usually these courses are taken in a math major, and there are lots of follow-up courses, and I'm going to make a series talking about them in turn. Now, my own area is commutative algebra, which I love, but I'm actually going to start with representation theory because I really want to talk about extensions of linear algebra. The representation theory basically joins linear algebra with something called group theory. Now, in abstract algebra, you'd learn that a group is basically a set of symmetries of something. For instance, if you have a square, there are 4 rotational symmetries. You can rotate by 90, 180, 270, or even 0 degrees. But if you add in some reflections, you're allowed to reflect across things, then you get some additional symmetries. And you learn about other groups as well, but some of the questions you might look at are like, how many are there? And for instance, how do they compose? For instance, down here, I've shown that if you first flip across the vertical axis and then do a 90-degree turn, that's actually the same as doing that same turn first and then flipping across a different axis. And I've tried to draw the picture down at the bottom to show what happens. The sorts of relationships that these different operations can have can be very complex, and it's very rich to study. Linear algebra, on the other hand, typically studies a single linear transformation, often encoded with a matrix. For instance, these 9 numbers here encode a linear transformation from R3 to itself. And throughout the course, you'll learn things like seeing when that transformation is one-to-one or onto. You might even look and see if it's stretching or rotating parts of the vector space. Probably the course will end by talking about eigenvectors and asking if the matrix is diagonalizable. This is basically trying to see, are there some vectors that are going to be special with respect to this one transformation? Representation theory puts these ideas together. So rather than looking at just one matrix at a time, let's look at all of, say, the symmetries of some shape and see if there's some matrices we can use that would encode the same types of properties that those symmetries had. For instance, if we were looking at the 4 rotational symmetries of the square, one of them is just rotate by 90 degrees. Now, one thing you might know about that matrix is that if you do it 4 times, it's going to be the same as doing nothing. Like doing 4 quarter turns is the same as doing nothing. And if you think about writing down matrices that have the same property, well, here's a 2 by 2 matrix that has that property. Here's a 1 by 1 matrix with that property. And there are like lots of different ways we can encode the fact that if you do something 4 times, in this case matrix multiplication, you're going to get back to the identity. So in other words, just for this one particular element, we're saying like, what are all the matrices you can write down that when you multiply them by themselves 4 times, you get the identity. Now do the same thing for every single symmetry of your shape. It may sound like this is a hopeless task and things are really complicated, but if you set things up in the right way, there's a beautiful story. And so if you want to try to find a way to represent every symmetry, you can kind of say, are there basic building blocks? Like this 2 by 2 matrix here seems to be built out of these 1 by 1 matrices here, but maybe not out of that one. And what about this thing up here? And then if you have those building blocks and you know you have them all, does everything kind of decompose like on a periodic table of elements? And then like, is there some like natural object that's maybe going to encode everything all at once? And sometimes in math, the answer is like, oh no, it's complicated. But here, there's actually a very, very beautiful, simple answer, at least when you're working over the complex numbers and you're dealing with what are called finite groups. If you've seen this before or you'd like to see more, let me know in the comments. I'm going to post lots of videos about this.